The amygdala is this relatively small structure. When I was in this class 20 years ago, they told us that the amygdala is the brain's alarm system, and that was about it. Now, today we know it is certainly that and responds very strongly to negative or threatening stimuli. But we now know that it responds to a lot more than that. It responds to really the presence of any emotionally meaningful stimulus in your environment. Let's just look at some data about what kinds of things activate the amygdala. And what we're looking at is here, it's circled there, and here, and you can follow it down. The amygdala very much preferentially responds to faces than shapes. You see your amygdala responding to all sorts of faces. Here, look at the subtraction maps. What you're seeing here are areas that activate more for fearful faces than for a fixation. Okay, fearful. How about happy? We see definitely amygdala. How about neutral? These are still faces after all. um, Now, fearful greater than neutral, and happy greater than neutral. If you zoom in on the amygdala, you see that forget about the clinical population. This was an adolescent group that had affect regulation problems. But if we just look at the dark control graphs, we see amygdala activating for fearful, happy, and also somewhat neutral stimuli. Now, because of its role in emotions, you would imagine that the amygdala plays a role in mental illness, and you'd be correct. In major depression and anxiety, the amygdala has been found to be enlarged and overactive. By overactive, we mean you show a control participant a stimulus, you show the patient the same stimulus. The patient's amygdala shows a much greater activation. So we surmise that it is overactivating because it is greater than a control group. Now, in major depression, you see that. In anxiety disorders, you see that. And how about autism? Autism is a very interesting disorder. I think most of you know what we're talking about. Here's a study, an older study. But what they did is they used eye tracking data and fMRI data. Now, not simultaneous, but subsequent studies would show the same thing. If we look at brain activation to faces and we compare controlled children to those with autism, we see that those controlled children show greater activation than the autistic individuals in this region. Where is this? This is the temporal lobe, and this is the inferior aspect of the temporal lobe. So this is part of the what visual stream. And this area is commonly referred to as the FFA, but that's gone out of favor, and now we prefer fusiform gyrus. It used to be more in vogue to call it the fusiform face area. But if you look at the autistic individuals showing greater activity than the control individuals, what do you see? You see the amygdala. And here you see that the autistic individuals activates significantly more. Uh, More data showing similar. This from UCLA. Um, so this was overall. Sorry, apologies. This was overall reaction to faces. What you see here is autistic individuals showing significantly greater activation. What was really interesting, what caught my eye in this, is when they broke down by angry and neutral in a condition where they forced everyone to look at the eye. Because the task was they put a blemish on one eye or the other, and your task was to say which eye the blemish was on, thus forcing you to look at the eyes. This is relevant because when you look at eye tracking while people look at eyes, controls tend to tend to do a pattern like this, whereas autistic individuals will tend to do this kind of a pattern. They'll settle into a pattern away from the eyes. However, what was interesting here is when you force everyone to look at the eyes, let's look at what you find. For angry faces, normal reaction. But look at neutral faces. Very exaggerated reaction. What you're seeing is now this is now interpreting data. You need more research to make bold statements like I'm going to make, so I'm throwing in caveats. The autistic individuals seem to be very aroused, even by neutral faces. Now, why that is debatable, but we could surmise a consequence of that. If every face you look at gives you amygdala arousal, you just may begin to avoid faces, which of course is a hallmark of autism, particularly um, when you're talking about more severe cases, but even with milder cases.